Hello everyone! Today we'll be talking about AI. And the first works in the field of cybernetics. Mathematical models would allow to get the first success of cybernetics provided article related to nervous activity. In it, Raven McCulloch and Walter Pizza posted their model. But the authors introduced several successful simplifications. Their model as a basis. It is an elementary logical unit, or in an inactive state. All signals were single. If the amount of input signals exceeded it, except standard excitatory bonds were inhibitory, regardless of the amount of other signals. That using the AND network. Let's look at the simplest. You need to use two exciting connections. For surgery A or B. Then it activates. Negation operation can be implemented using, for example, for surgery A and not B. C is activated only if activated A and not activated B. Transistor is also an elementary logical unit. And thanks to the competent combination of transistors in the circuit, able to perform any calculations. The first transistors were developed around the same time. Not electrical engineering. Engaged in central information processing. But the main thing that you can notice in this work, the model should be able to derive from the data. That will allow you to use the model to solve such problems. McCulloch's neuron. Who tried to build training models based on it? Published by a young scientist in an article titled Perceptron. Managed to combine some of the most successful ideas. The perceptron was a model of several hundred Meckel neurons. Instead of arbitrary configuration, consisting of several layers, unlike modern neural networks, with all the neurons in the next layer, which showed the redundancy of so many connections. Each neuron communicated with some amount of random. Neuron model. Each neuron has its own activation threshold. Instead, Rosenblatt set the same threshold, but made all ties weighted. Finally, Rosenblatt suggested learning rules, that neurons on the left contain input. The last layer had one or more neurons. All connections between him. Weighted some of their signals. If the output neuron, all connections between it and activated neurons. This rule applied to all neurons in the output layer. That he was complete. And what tasks it solved and how it was implemented. Images were used as input data. It was communicating with the input neurons. Between intermediate and output neurons. But having an intermediate layer allowed the perceptron a combination of random groups of pixels. In the process of learning, and perceptron weights were updated after each image. For example, the perceptron did a great job classifying. Besides perceptron, was that a real physical computer with own manual on 65-page weight, which were automatically configured using the system. And to some extent this actually happened. Perceptrons was actively working on other models. In 69th year, former fellow student of Rosenblatt. In this work, at that time models, feasibility of use. Their ideal was artificial intelligence. Perceptron and Minsky called speculative biology, which Minsk paper brought for that. That flaw was invisible. As in the case of images, took a very simple task, which can only take 2 meanings. He is unlikely to have problems with that. Unlike regular IL, when both variables are equal to units. Set aside values A. Since we ended up in two-dimensional space, how the decision is made. Data on some coefficients. And on the other side to the other. Instead, the boundary will be a plane or hyperplane. For example, logical and logical. Impossible feel. For its perfect work. Important to notice. Multilayer perceptron will consist of polygons. So, albeit with partially fixed connections. What was stopping him from going further? They were the ones directly influencing the response, which had only an indirect effect on the result. Rosenblatt on the potential of perceptrons. That interest in perceptrons began to fade. He was shocked by the article, in which he himself participated, that I is not just a sensor. Meaningful information about the presence of objects and movement. This shook Pizza's views and his brain vision. For centralized information processing, Pizza destroyed its research. Other researchers following Minsk. Cybernetics funding has declined dramatically. With this could end the history of neural networks. But useless models. That in just 5 years. Doctoral dissertation is the missing one. Error backpropagation algorithm. In fact, he was in association. Differentiation of complex functions is a universal approximate search algorithm, which uses applied to perceptrons. On training sample, performed through a series of steps. Its value characterizes the contribution of this parameter to the error. Current parameter value multiplied by a small number, which corresponds to the minimum deviation of the model. This algorithm sounds far from as clear, but it has a significant advantage. Unlike Rosenblatt rule, which directly affect the response, but there is a difference in terms of calculation. Verbose and suggested using the rule. W1 and W2. Through the product of simpler derivatives, considering the work of the model in the opposite direction, predictions directly depends on W2. W1 will need one step more. Model deviation depends on prediction. If you're not sure, you can just cross out the same multipliers and make sure. Depends on loss function and activation function. Derivatives by all parameters, until model deviation reaches minimum. That was supposed to change things and give a new impetus. Verbose was doing social sciences. Since the scientific community at that point exchanged information, but same year, it described the cognitron model as Rosenblatt's perceptron, and Focusy managed to train her without using the algorithm at all. Similar to learning without a teacher. An image was fed at the cogniton input. Each neuron connected to the neuron directly opposite, as well as in Rosenblatt's perceptron, changed during the learning process. Neurons' foci were non-binary. Later from this basic neuron property, but we focus. In response to each image, the neuron was activated with, and at every site, which activated stronger than the rest. Specialized in certain. Neurons could be responsible for angles. Reacted already to unique. For example, geometric shapes. Could classify the object in the image. That these neurons most often reacted to units, and unfreeze these. The next significant successes appeared only later, which better matched the spirit of the new time. The focus was on. This was done by neuroscience, memory, and complex human behavior. Instead of answering the question, how we think, Jeffrey Hinton and co-authors published two papers at once. Too many questions to Nettie Sticka. Parallel distributed representation. But its main position can be attributed to as complex patterns of neuron activation. which was played by Minsk Papert. Most of the neurons in the brain. Whole images. This was way less likely. It meant able to isolate in complex objects without explicit instructions, shape, color, or angles. Focusing. Focus was also inspired by the works of early Rummel Hart-Hinton and the authors. Representations by backpropagating an error. Error backpropagation. Regardless of verbose gender, how we remember. But remarkable then, they applied this algorithm to learning. Their training was considered in principle impossible, which prevented the implementation of the learning algorithm, which has existed since the days of the neuron macroscopic. Inactive. And since the learning algorithm half consisted of calculating, with solving the problem of learning multilayer models, and new discoveries about the work of perceptrons, it better reflected the essence of the approach. This period is also final, convolutional, neural networks, and other sequences. Pretty similar than previous researchers. I suggest starting with convolutional neural networks. In his work, in it, he emphasized the lack of early models of vision, that each neuron combined with image points. Each neuron responds to a specific pattern, but this model had a clear flaw. For example, angles may appear in different parts of the image. Model is more efficient. Significantly reduce model accuracy. Could get completely unfamiliar patterns for them. Of the modified model from later works foci to anti-pattern detection from position. Besides the lick, he made all the connections more structured, and from each point in a small window 3 by 3. All neurons reacted to the same pattern. You just needed to increase the number of layers, but were different from the scales in the other layers. Neurons in deeper layers. Previous layers. Layers at this level could also be several. Final layer was like a perceptron layer. Based on the analysis of patterns combinations at each position, one of the earliest versions of a convolutional neural network. For model training, earlier layers were trained to find the most important, and the final layer to make a decision. In this same work, model results. She achieved incredible accuracy, closest to the model in the first line, and perceptron. It's a model in the second line. Recurrent neural networks. text processing, and other complex sequences. Text unlike other data types. When analyzing the text, it is important to remember various facts. One solution to these problems. Updating the internal state of the model at every step. The current context. This is so old idea. More to the original work Macaloka Pizza. Developed this concept and offered different versions of models. Described in the article Structure Search in Time. Able to cope not only with text generation, but before we get to the model itself, which Elman solved, the vocabulary in the Elman language was simplified. Of 5 characters, where only one bit was equal to 1. Part of speech rude. About every word completely discarded. Elman created a corpus of synthetic text. Nevertheless, the text was not so simple, could be clearly understood from context. This enclosure was used for model training and had to predict the next word. Could learn to memorize 2-word phrases so that the model has the opportunity. Elman added another hidden recurrent layer and bicyclic communication with itself. Thus, added to memory and changed and gradually. And the connections between the hidden layers were learnable. What out of context is important at this point? Accuracy, as far as possible in tasks. But the most amazing thing was not this. To remember a few previous sequence words. Information compression and more efficient text generation. Syntactic and semantic model of language. Followed a clear structure, as well as all nouns. The model identified groups with similar meanings of words. But despite all the success, ironic, but his development was prevented by almost the same reasons. First, then, that layers can be as many as you like. 4 layers were practically unteachable. This was caused by a combination of negative factors. Who succumbed to training? Due to lack of data and weak iron. Each group of researchers collected data independently. Hundreds and thousands of objects. Computers of that time have not been built on the electron lamp system for a long time, but their performance was still negligible. I will do unforgivable things, but just for awareness. Released in 95th year. It's 4 times lower. And Janu Licken, for example. Great successes of the first works again forced researchers too. And investors who were initially delighted. All this was accompanied by support vector machines and nuclear methods appeared. Models from the field of classic chalk. Mainly due to lower requirements. But fortunately, this time, work continued. Even managed to unite scientists from different universities. Continued to improve existing models. In '97 came out work on LSTM, with extra track for long-term memory. And other sequences much. That used to be a big problem. In size and quality, consisting of 70,000 handwritten characters. Benchmark for new models. For 10 years. Leonid 5 also released in '98. But the final step, published by Geoffrey Hinton in 2006. Deep-Live Network, and Hinton managed to train her, and was about model training. Parameters of other layers were fixed, but already entirely. But like always, two important changes took place during the second winter. Go to the third and final climb. This is the rapid development of the gaming industry. Assassin's Creed. And working with graphics was so hard. Thousands of graphical primitives in real time. Use fast graphics cores. And to speed up the training of neural networks. Specialized graphics cards with tensor cores. Appeared in consumer segment video cards, which contributed to the rise. Ready datasets went beyond universities. Grew almost exponentially. Created in '98 under the direction of Yin. But it's 70,000 images. But it would be basically impossible. In some cases not required at all. In due time without demand. To create search engines, GitHubs and other resources to train your models, which showed the possibility of learning for real, and together served as the beginning of a new era. The term deep learning, emphasizing complexity and number of layers, somehow related to neural networks. Since that moment, discoveries have happened so often. From appearance and total domination. In just 5 years. Stopped being relevant. Transition to more successful algorithms of weight initialization and more complex optimization algorithms like Atom. Suggest a short walk without names and detailed descriptions, or else you will study them. Work in this area. Developed by Leakin on the ribbon of the '90s and noughties. Published in 2012. Which gave her a huge advantage. AlexNet surpassed new model VIGG. And in 2015 was published Race No Authors. Later in 2019. That the effect of increasing the number of layers can be and once again surpassed all previous models and allowed to focus mainly the existing architecture. Long time neither LSTM. Coping with long texts. To the most important breakthrough in the history of deep learning. All you need is attention. No recurrent approach. Transformers. What allowed? Including modern LLM agents like ChatGPT. Despite the excellent results, due to the huge number of parameters and training costs, but finally surpassed convolutional models and in language processing tasks. New models are getting bigger. Ambitious next goal now is AJ. Some researchers believe, and that the main limitation. What for real AJ? Fundamentally new approaches and ideas will be required. Then in 2024, and overheating expectations in the age of consciousnism. That AJ is unreachable. Actually, these fears are exaggerated. Engineers and data scientists are weakly dependent on ages, technology, and everyday life. Networks were able to digitize. And marketplaces. And even if the revolution does not happen, well, if the age is still achieved, I think the future is more likely to be like idiocracy, which I would like to discuss. This analogy worked both ways. Then the achievement of cybernetics and connectionism. But today it is important to understand mathematical modeling of the brain. It's a separate discipline. These models create not to predict growth. Their purpose is solely in understanding neural networks in turn. If you trace the origins of the key ideas of recent years, then you will see that they are taken from other areas, like stepped activation functions. Although cannot be excluded, can give new ideas for deep learning. At the moment, it's two very distant areas. You were wondering to go all this way along with me. Few of them were lucky enough to see, but thanks to them, many researchers I mention here only in a word, so you don't get lost in the stream of surnames. And if you are interested not only in the history of neural networks, One thing you can be sure of.